Welcome to 3 Inquisitive Kids. In this video, we will be doing many practice problems using the sum and difference formulas of trigonometry. We can keep the first term for now, but we can rewrite our second term. Sine of 62 degrees is the same thing as 90 minus 28. And cosine 51, the 51 is the same thing as 90 minus 39. As you can see, 28 and 39 now appears multiple times. It must mean we're on the right track. And we can apply one of our sum and difference formulas. Sine of 90 minus 28 is the same thing as sine of 90 times cosine of 28 minus cosine of 90 times sine of 28. And this entire thing is being multiplied to our cosine term, which can also be rewritten using a sum and difference formula. We could have cosine of 90 times cosine of 39 plus sine of 90 times sine of 39. Now, we already know what sine 90 is. That is just 1. And cosine of 90 is 0, so 0 multiplied to anything is 0. We're left with cosine of 28 degrees times, now what do we have in the second brackets? Cosine of 90 is equal to 0. Sine of 90 is 1. We have sine 39 degrees. Looking at our structure here, we can now use the sum and difference formula again, but backwards. It's the sine sum and difference formula. So this is the same thing as sine of 28 degrees plus 39 degrees, which is just sine of 67 degrees. And there we go, we have simplified our expression. Now let's find what is sine of 15 degrees without using a calculator. And this is very doable. First, we can use some of the common trigonometry values that we already know and try to represent sine 15 using those numbers. Sine 15 can be represented as sine of 45 minus 30 degrees. And now we can use our sum and difference formula. Sine of 45 degrees times cosine of 30 degrees minus cosine of 45 degrees times sine of 30 degrees. And we already know what each of these values are. Sine of 45 is square root of 2 over 2 times cosine of 30, that's square root of 3 over 2, minus square root of 2 over 2 times 1/2. Let's simplify. We have square root of 6 over 4 minus square root of 2 over 4. So square root of 6 minus square root of 2, all of that over 4. And this is our answer. We're given that cosine of theta is equal to negative 12 over 13. And this angle theta is from pi, which is 180 degrees, to 3 pi over 2, which is 270 degrees. This means if we're looking at the coordinate plane, the edge of the angle theta lies in this third quadrant. We are told to evaluate the cosine of theta plus pi over 4, which is the same thing as theta plus 45 degrees. So now let's take what we're trying to solve. Cosine of theta plus pi over 4. Using our sum and difference formula, we can rewrite this as cosine of theta times cosine of pi over 4 minus sine theta times sine of pi over 4. And we know that cosine of pi over 4 and sine of pi over 4 are both equal to square root of 2 over 2. So we can factor that out. We have square root of 2 over 2 times the difference of cosine theta and sine theta. We already know what cosine theta is. Cosine of theta is just negative 12 over 13. Now we have to find what sine theta is. All we have to do is use the Pythagorean theorem. We know that sine squared plus cosine squared is equal to 1. So, sine squared in this case, for us, will be equal to 1 minus cosine theta squared, which is 144 over 169. Now, when we do that, we get sine squared of theta is equal to 25 over 169. So, sine theta must have an absolute value of 5 over 13. And now, let's determine if sine theta in this case is positive or negative. Because we're talking about an angle that is located in the third quadrant, the sine, same thing as the y value, must be negative. So, sine theta in this case is just negative 5 over 13. And now we're going to subtract sine theta from cosine theta. So that's the same thing as adding 5 over 13. We have square root of 2 over 2 times negative 7 over 13. This gives us negative 7 times the square root of 2 over 26. And that is our answer. Here is our next problem. The cosine of alpha minus beta over 2 is equal to negative 1/9. Sine of alpha over 2 minus beta is equal to 2/3. We know that alpha is an angle that's between pi over 2 and pi, which means that this angle alpha is between 90 degrees and 180 degrees. And beta is between 0 and pi over 2, which means beta is between 0 and 90 degrees. Our task is to find alpha plus beta divided by 2. So we have 3 expressions here. We can name them 1, 2, and 3. In a case like this, we always try to write the unknown, in this case 3, in terms of the known, in this case 1 and 2. Well, if we take number 1 and we subtract 2 from it, what do we get? We have alpha minus beta over 2 minus alpha over 2 minus beta. This is the same thing as alpha minus beta over 2 minus alpha over 2 plus beta. This is the same thing as alpha over 2 plus beta over 2, which is alpha plus beta over 2. This is exactly what appears inside the expression we're trying to solve for. So we can rewrite our expression that we're trying to find, cosine of alpha plus beta over 2, as cosine of alpha plus alpha minus beta over 2 minus alpha over 2 minus beta. Now we can apply our sum and difference formulas. We have cosine of alpha minus beta over 2 times cosine of our next term plus sine of the first term times sine of the second term. Now we can use what the problem already told us. Cosine of alpha minus beta over 2 is equal to negative 1/9 times this. We can leave it for now, but we can be able to solve for it later using the Pythagorean theorem. Plus sine of alpha over 2 minus beta. That's equal to 2/3. We can keep this term. Our next step is to solve for the cosine of 1 and the sine of 2. So, using the Pythagorean theorem, let's call this cosine term x. We're trying to solve for it. we know that the sine of the same angle is equal to 2/3. So 2/3 squared plus x squared must be equal to 1. It means that x squared is equal to 1 minus 4 over 9. So x is equal to the square root of 5 over 9. And now let's try to solve for sine of alpha minus beta over 2. We can call this y. Y squared plus negative 1/9 squared, which is 1 over 81, must be equal to 1. So y itself must be the square root of 80 over 81. Now we can substitute. We have negative 1/9 times square root of 5 over 3 plus 2/3 times square root of 80 over 9. We have negative square root of 5 over 27 plus 2 times the square root of 80. We can rewrite this as 2 times 4 times the square root of 5 over 27. And so we have 8 square root of 5 minus square root of 5 over 27, which is 7 times the square root of 5 over 27. So our original expression, which was cosine of alpha plus beta over 2, is equal to 7 times the square root of 5 over 27. We were able to solve this by writing what we're trying to find, the unknown, in terms of what we do know. Here's our next problem. We are given that the tangent of alpha is equal to 2, the tangent of beta is equal to 3, and both of these angles, alpha and beta, are acute. We're going to try to find the sum of these two angles. So before we start, we need to write out a formula for tangent. Tan of alpha plus beta, so the tangent of the sum of two angles, is equal to tangent of the first angle plus the tangent of the second angle over 1 minus their product. So knowing this, we can do many things. We already know what tan alpha and tan beta are. That's the same thing as 2 plus 3 in the numerator. And in the denominator, we have 1 minus 6. So we're left with 5 over negative 5, which is equal to negative 1. This means that tangent of the sum of these angles gives us negative 1. Now, when does this happen? Let's think of it on our unit circle. We know that tangent is the ratio between sine and cosine. And you can only get 1 if the sine and cosine are equal. And we know this only happens when we have 45 degrees. And when we have the opposite of that. So that would be 225 degrees. Because at that point, both sine and cosine are equal to the square root of 2 over 2. So when we have square root of 2 over 2 over square root of 2 over 2, we have an absolute value of 1 for the tangent. But remember, in our case, the tangent has to be negative. This means that our angle must be in the second and fourth quadrants, because this is when one of the sine or cosine is negative. So their signs are different. If we have a 135 degree angle, then tangent of alpha plus beta would be negative 1. If we have a 315 angle, the tangent of that will also be negative 1. So we have two possibilities for our answers. But remember, alpha and beta are both acute. This means that if they're both acute, alpha must be less than 90 degrees, and so is beta. So alpha plus beta must be less than 180 degrees, which means that their sum can never exceed 180 degrees. So their sum cannot be 315 degrees. That would be too much. Which means that the sum of alpha and beta must be 135 degrees. So alpha plus beta this is our answer, is equal to 135 degrees. We're given that two acute angles, alpha and beta, satisfy cosine of alpha is equal to 2 times the square root of 5 over 5, and the cosine of beta is equal to square root of 10 over 10. We want to find what is the value of alpha minus beta. Let's see how we can rewrite an expression that includes alpha minus beta using what we know, which is cosine alpha and then cosine beta. Well, if we take sine of alpha minus beta, we can use a formula, which is sine alpha times cosine beta minus cosine alpha times sine beta. And we already know what cosine beta and cosine alpha are. They are just square root of 10 over 10 times sine alpha minus 2 times the square root of 5 over 5 times sine beta. And we can find what sine alpha and sine beta are just by using the Pythagorean theorem. Let's first find sine of alpha. Sine of alpha squared plus cosine of alpha squared must be equal to 1. So we take cosine of alpha squared plus what we're trying to find. It must equal to 1. So sine of alpha must be equal to the square root of 1 minus 4 times 5 over 25, which is equal to square root of 1 minus 4 over 5, which is equal to square root of 1/5. So that's what sine alpha is equal. Square root of 10 over 10 times 1 over square root of 5. And now what's sine beta? Sine beta would be equal to, if we apply the Pythagorean theorem, the square root of cosine beta, so 10 over 100, that subtracted from 1, and you could take the square root of it, so it's 90 over 100 under the radical, which is the same thing as 3 times the square root of 10 over 10. And now let's simplify. We've all ended up with numbers, no more trigonometries. The 1 over square root of 5 is the same thing as square root of 5 over 5. So we have 5 times square root of 2 over 50 minus 6 times 5 times the square root of 2 over 50. This is the same thing as 5 times the square root of 2 minus 30 times the square root of 2 over 50. So we have negative 25 times square root of 2 over 50, which is equal to negative square root of 2 over 2. And that is our answer for what sine of alpha minus beta is. But we're going to actually find what alpha minus beta it is itself. So in what cases do we have sine of an angle is equal to negative square root of 2 over 2? Well, when we have sine of 45 degrees, the sine of that is positive square root of 2 over 2. Well, we're going to take this base angle, but make it go into the third or fourth quadrant, because in the third or fourth quadrant, the sine is always negative. So sine of 225, for example, is equal to negative square root of 2 over 2. Or it can be sine of 315 degrees is equal to negative square root of 2 over 2 also. But remember, alpha and beta have to be acute. Well, if alpha and beta are both acute angles, either they equal each other and the difference is equal to 0, or alpha is greater than beta, so we have a positive, or alpha is less than beta, and we have a negative. So let's look at our two situations. Clearly, none of these situations do we have 0 as an acceptable angle for alpha minus beta. So alpha minus beta cannot equal 0. And is it possible for the difference of two acute angles to be 225 or 315? No, it's too large, which means the difference of alpha and beta cannot be positive, which means that beta must be greater than alpha. And when we subtract beta from alpha, we're getting a negative angle. So 225 degrees, we can actually rewrite it as a negative angle. Instead of saying that it's equal to this angle, we can say that it's equal to this angle. So that would be 360 minus 225, which is 135. So we can say that sine of negative 135 degrees. And same for 315. That's the same thing as negative 45 degrees. So the difference of alpha and beta can either be negative 135 or negative 45. But remember, alpha and beta are both acute angles, which means that if we subtract one from the other, we would never get 135. That would be way too big. Which means that negative 45 degrees is the only possible value for the difference of alpha and beta. Which means that our answer, the value of alpha minus beta, is equal to negative 45 degrees.